Hello viewers, in today's class we are going to solve yet another problem related to absolute value function, and here we have to solve this integral from -1 to 1 e raised to absolute value of x, right? So let us start, right? So let us first call this integral as I, right? Now here we see that our integrand which is f of x is equal to e raised to mod of x, and here we have to first utilize the definition of absolute value function, right? So here x varies from -1 to 1, right? So if we take these two numbers on the real number line, we see that here we have -1 and here we have 1, right? And between -1 and 1 we have the number 0, which lies somewhere here, right? Okay, so now we know that from the definition of absolute value function, that is mod of x is equal to positive x whenever x is greater than or equal to 0, and mod of x is equal to minus x whenever x is less than 0, right? So here if we look at this figure, then we see that whenever x is greater than or equal to 0, then this absolute value of x is positive x, and we see that in this interval, right, to the right of 0 we have x greater than 0, right? And towards the left of 0 we have x less than 0, and this is the point x is equal to 0, right? So what we will do here, we'll break this integral as a sum of two integrals, right? I1 and I2. So why we are breaking it? Because I1 will go from -1 to 0, right? That is -1 to 0, and in this interval x is less than 0, right? So we'll take mod of x is equal to minus x, and when x belongs to this interval, that is from 0 to 1, x is greater than 0, so we'll take mod of x is equal to positive x, right? So now I1 is from -1 to 0, and we have e raised to mod x dx, and I2 is from 0 to 1 e raised to mod x dx, right? And for this mod x, we can now write e raised to minus x, because from -1 to 0 x is less than 0, so mod of x is equal to minus x, right? And similarly here we have 0 to 1 and e raised to mod x, so mod x is taken as positive x, because x varies from 0 to 1 and we have x greater than 0, so here we'll take mod x is equal to plus x, right? Okay, so now we have here two integrals, and now we can easily solve these two integrals, and we know that the integral of e raised to x is e raised to x. So here e raised to minus x is e raised to minus x, and the limits are from -1 to 0, right? And here we have e raised to x, so we have the integral e raised to x, limits are from 0 to 1, right? Okay, so now we can simply substitute the limits, and we'll take the difference. Now taking here negative sign outside, so we have e raised to -0 minus e raised to minus 1, right? And here we have e raised to 1 minus e raised to 0, right? And now here we have e raised to 0, and e raised to 0 is 1, and we have 1 minus e raised to minus minus plus, so we have e raised to 1, and here we have e raised to 1 minus 1, right? Okay, so now this term can be written as minus 1 plus e, and here we have e minus 1, so we have e plus e is 2e, and minus 1 is minus 2. So we can write it like this, taking 2 common, so we have 2 times of e minus 1, right? So the value of this integral from minus 1 to 1 e raised to mod x dx is given by 2 times of e minus 1. So where e is the famous exponential number, and which lies between 2 and 3, right?